Okay, here are the example questions for altitudes. Example A asks us which line segment is the altitude of triangle ABC. Recall that the altitude of a triangle is the distance from one of the vertices of the triangle to the opposite base. So if this is our vertice, then the distance between it and the base of the triangle down here would be the altitude. So in this section, what we're looking for is looking at the triangle from this perspective. We're looking at either this base here. Well, in fact, we're just going to look at that base here. We're assuming we're dealing with line AB as our base and C as our vertex. So we're looking for that distance between line AB and vertex C. And the line segment that's the altitude then, of course, would be BC. And it is one of the line segments because this is a right triangle. Remember that on a right triangle, the altitude of the triangle is one of the legs. Okay, let's take a look at example B. Example B says a triangle has angles that measure 55 degrees, 60 degrees, and 65 degrees. Where will the altitude be found? Well, all three of these angles are less than 90 degrees, which means that this is an acute triangle. And on an acute triangle, the altitudes are all found inside of the triangle. And we can see that with a quick sketch if we were to draw ourselves an acute triangle here. All three altitudes, from here to here, from here to here, and from here to here, all three of those are inside the triangle. So if it's an acute triangle, your altitudes are inside. And then finally for example C, it says that a triangle has an angle that measures 95 degrees. Where will the altitude be found? Well, since 95 degrees is greater than 90 degrees, this would be an obtuse triangle. So an obtuse triangle is a little bit wider than 90 degrees on one angle, like so. And on an obtuse triangle, the altitude of the triangle is outside of the actual triangle. It's back over here somewhere, yeah? So outside is our answer. That's it. Pretty quick one.